This is transmission line analyzer, model number TLA05. Switch on the instrument from the back panel. Now this is the impedance bridge. It goes from 0 ohm to 1 kilo ohm or roughly 800 ohms. This is the unbalanced load. This is a frequency output source which goes from 30 megahertz to around 300 megahertz with the help of this tune pot. Now it is showing around 7 megahertz as the lowest frequency, and here it is showing around 300 megahertz as maximum frequency, whose sweep or bandwidth can be controlled with the help of a span pot. Now there are two outputs, horizontal and vertical, which can be used to display the frequency sweep of this frequency source. Then there is one more portion of transmission line analyzer, that is TDR, time domain reflectometer. It has got short range and long range. Short range gives a pulse output of around 10 megahertz with a 1 volt peak to peak level roughly, and similarly this gives a typical 100 kilohertz of pulse waveform with 1 volt peak to peak output. Now let us start with the frequency response of cables by connecting horizontal and vertical output to any oscilloscope available in your lab. For example, we are using a DSO here. One can use an analog oscilloscope as well. Now put the oscilloscope in XY mode. Some oscilloscopes have got a direct XY switch. Press that switch. Now there is a spot coming on the display which indicates that the display is now in XY mode and the no time base is used now. Use XY cables. These are XY cables. These are ordinary cables because they don't have a very good frequency response, so they are used for DC. The horizontal output is actually a triangle waveform. Now X output is connected to channel 1. Now see, the moment X output is connected to channel 1, we see a line. Then there is another XY cable which is connected to vertical output. Vertical output is nothing but DC output of the frequency which is displayed here. There is basically a detector inside it which converts the RF frequency into DC voltage. Now this output vertical is connected to the Y channel or channel 2. Now what you see is a frequency response. If your display doesn't come, then you have to select the attenuators of voltage at X or Y. Now here it is less, you have to select it accordingly so that the display almost comes in the center. Now to ensure that we are measuring the center frequency, because whatever is displayed here is actually the center frequency. If I remove the Y cable, I can see now this has to be precisely put to the center. Now this is actually 136 megahertz which is being displayed here. Now we put it to 150 megahertz. Now the frequency here is actually the center frequency. Now the center frequency is this. So when we are keeping the display at 150 megahertz center frequency, that means this is supposedly the low frequency and this is the highest frequency, that is roughly around 300 megahertz. And the coupling has to be DC so that the waveform doesn't go left or right. Okay, now what you are seeing is actually the frequency response and this is a calibrated attenuator. So suppose if I press 0.5 dB, I could see 0.5 dB on oscilloscope is roughly this much. If I press 1 dB, I could see 1 dB is this much, 2 dB is this much, 4 dB is this much, 8 dB and 15 dB, almost 0, which again can be amplified with the help of voltage variable attenuator. Okay, now let us take a cable. This is RG58 cable, 4.6 meter length, and the characteristic impedance of this cable is 50 ohms. Now the moment I try to feed energy with the help of this frequency source into this cable with other end being open, what I see is number of multiple standing waves. Now here the span is kept fully clockwise so that you are seeing the complete frequency response. Now if I turn the span anti-clockwise, I can see a particular standing wave at 150 megahertz. Now if had the span been almost 0, then I could have only see a maxima, but here the span is kept little, say like 10 megahertz or 15 megahertz, so that one can always see a standing wave being formed. Now as this end is open, so the VSWR is maximum, and if this end gets shorted, you can see the VSWR again is maximum. So now you can see the moment I connect this cable, now it is open circuited, and the moment I connect it on a short, the maxima changes to minima.